Hi, this is Alex from devstories.eu. GeoPandas, episode 6 of 11. Your geospatial queries are taking hours to run, freezing your machine and draining your patience. You are probably making your CPU check every single point against every single boundary, which scales terribly. The solution to this bottleneck is Turbocharge queries, the R-tree's spatial index. You have 1 million GPS points in 50 neighborhood polygons. If you test every point against every polygon to see which neighborhood it belongs to, you execute 50 million complex geometric calculations. Finding if a coordinate rests inside an irregular polygon is a heavy math operation. Doing this as a full scan creates an exponential scaling problem that destroys performance. A spatial index solves this by acting like a table of contents for your map. GeoPandas uses a specific structure called an R-tree, built using the sort-tile recursive algorithm. The R stands for rectangle. The tree groups objects logically based on their location. The key insight here is the pre-filter. Instead of checking the exact jagged borders of a neighborhood polygon, the index draws a simple rectangular box around it. This is called an envelope or a bounding box. Checking if a coordinate falls inside a basic rectangle requires almost zero computational effort. The index immediately discards any point that is not even inside a neighborhood rectangular bounding box. You instantly narrow down the candidates from 1 million to maybe a few thousand. This brings up a critical two-step reality of spatial querying. A hit on the spatial index only means the bounding boxes intersect. A point might sit inside the rectangle, but just outside the actual curved boundary of the neighborhood. The bounding box hit is just step 1. Step 2 is the exact geometry check on that smaller subset of candidates. You access this engine through the sindex.query method. If you pass a single geometry, it returns an array of integer indices corresponding to the geometries in your geoseries, whose bounding boxes intersect your input. To force the index to handle that crucial second step, pass the argument predicate equal to intersects. GeoPandas will then use the cheap bounding box check to find candidates and automatically run the expensive exact geometry check on just the survivors. You can also pass an entire array of geometries into the query at once. This array query returns a two-dimensional array of indices, pairing up the matches between your input array and the indexed geoseries. The first row gives the index of your input geometry, and the second row gives the index of the matching geometry in the tree. Sometimes you do not need an intersection, you just need proximity. The sindex.nearest method takes an input geometry and returns the index of the closest geometry in the tree. This is highly efficient for snapping a stray coordinate to a road network or finding the closest weather station without calculating the distance to every single station on the continent. Complex spatial operations are mathematically expensive. Never force your CPU to calculate exact geometric intersections when a simple rectangle check can eliminate 99% of the candidates up front. If you find these episodes helpful and want to support the show, you can search for DevStories EU on Patreon. That is all for this one. Thanks for listening and keep building.